Hello and welcome everyone to the video. In this video, we'll be looking at logarithm as a topic, and it happens to be a very, very important topic. And also it happens to be a very, very scoring topic in any of the aptitude papers for that matter. So we will then look at logarithm as a topic for the day. And before we move on to logarithm, let us understand that there's a lot of value attached to understanding the graphs of any of these functions, whichever we'll be talking about in this entire series. So today I'm talking about logarithm. We will also talk about modulus and greatest integer function and things like that. So at every point in time, I want you to really understand the graph of these functions, because once you develop the graph of these functions on your own, you will never fear these questions at all. And most of these, or rather some of these questions, which will be very straightforward if you look at the graph. Okay, so let's get on and let's look at logarithm as a topic. And of course, I will start by generating the graph of the logarithm and of course, talking about the meaning of logarithm. So if you talk about the word logarithm, it is nothing but a way of expressing your exponential function. So for example, if I have an exponential function which says that a to the power of x, which is equals to y, I can rewrite this as a logarithm function which says log of base a, y, and x is the input. Right now, over here, y becomes the input value and x becomes the output value. Now, in general, what we look at is we look at y as the output value and x as the input value. That's the general trend that we look at, or a convention that we follow throughout. So we will rewrite this as a to the power of y is equals to x. Let's say, suppose this is the value. Then what we can write is log of base a, x is equals to y. So this can be interchangeably written. So when you are writing, whatever is the relationship between x and y over here will be the same relationship between x and y over here, provided that the value of a is a constant. So you are not changing the value of a, you are putting in some of the values of y and checking what will be the value of x over here. Right? And then when we plot this on the graph paper, we will get the graph of the log function. So whatever is the relationship over here between x and y will be the relationship between x and y over here. So if I am able to generate the graph for this, I will be having the same graph for this as well. Right? So let us now try and evaluate the graph of this. Now, there's an important aspect of entire logarithm, which is of course based on the understanding of exponential function. So when you look at exponential function and when you look at this base, it is very interesting to read this base. Okay, so let me say that I'm taking the value of base as 2. Now, if I take the value of base as 2 and I start changing the values of y, so let's look at some of the values of y and try and get down to the values of x. So let me say that I'm taking the value of y as 0. My value of x will be 1. Same way, let me take the value of y as 1. What will be the value of x? It will be 2. If I've taken the value of a as 2, so this will be 2 to the power of y. So 2 to the power of 1 will be 2. If I take the value of y as 2, it will become then 4. Same way, if I take the negative values of y, what happens? So suppose if I take the value of y as minus 10, then what will I get? I will get 2 to the power of minus 10. I'll get 2 to the power of minus 10, which is 1 by 2 to the power of 10. Then what can I say? 1 divided by a very large value. 1 divided by a very large value is of course a positive value, but is a small value. So positive small value is what we're going to write over here. Right? It can be any of those values, but I'm just telling you that it is going to be a very, very low value. Now, observe something more, that over here, when the value of y was increasing from 0, 1, 2, and if you then keep on increasing the value of y, you will realize that the value of x will also be increasing. So there's a direct proportionality that you are looking at. And when you are going into the value of y less than 0, then what is happening, that it is still reducing, right? So now let us have a look at a value of a being 0.1. This is for my convenience that I've taken so that I can calculate the values easily. So if I take the value of a as 0.1 and choose some of the values of y and see what are the values of x from this function, we will see what happens. So let's say, suppose if your value of y is 0, so 0.1 to the power of 0 will then turn out to be equals to 1. If you take the value of y as 1, then 0.1 to the power of 1 will be 0.1. If you take the value of y as 2, 0.1 to the power of 2 will become 0.01. This implies what? Now, when you are increasing the value of y, your value of x is reducing. So your function is now behaving in a different way. That means for my value of a being greater than 1, you will have a certain behavior, which is right there over here. And when the value of a is between 0 and 1, you will have a different behavior from the function, which is present over here, right? So now the same thing is going to apply to the log function. That means we will have to evaluate the log function in two different bases. One time the value of base should be greater than 1. Another time the value of base should be less than 1. And as I told you, that exponential function and the logarithm function can be interchangeably written. That means whatever is the relationship between x and y that you are getting over here for the exponential function will be similar to what you will be getting for the log function, or rather it will be exactly same. So let me just put the graph over here and let's see how does the graph of the log function behaves. So your value of y-axis and your x-axis over here. Now let's first evaluate the graph where the value of a is greater than 1. So I'm talking about the values of a being greater than 1. Now, if your value of y is 0, your value of x is 1. Now, where is y 0? Y is 0 on the entire x-axis. Now, when I'm saying x is 1, I'm talking about this particular point, right? So this is the point that we are talking about. This is y0, x1. Now, when you are increasing the value of y, your value of x is increasing. Correct. So now if I put a very high value of y somewhere over here, what will happen to the value of x? It will be a very high value of x. So can I then say that this is a generic point on my graph? For a very high value of y, I get a very high value of x, right? So there's one point over here, which was x1 and y0. There was another point over here, which is a very high value of y and a very high value of x. Right now, let us take a highly negative value of y. If I take a highly negative value of y, your value of x is turning out to be a very small positive value of x. So very small value of x will be closer to origin over here, and the value of y is a highly negative value. So can I then say that this is a generic point once again on my graph, right? So these are the three generic points on my graph. If I join these points with the help of a free hand, I'm going to get a graph that moves like this. So this is the graph of your log function when your value of the base of the log function is greater than 1. So a greater than 1, this is the graph that I'm going to refer to, right? Let us now develop the graph for a line between 0 and 1. A line between 0 and 1 is what we will be looking at. So now, if you have a value of y as 0, your value of x will be 1. Once again, you will have a point, this particular point on your graph. Right now, when you are increasing the value of y, your value of x is reducing. So if you put a very high value of y over here, let's say suppose I put 1000, so 0.1 to the power of 1000, it will be a very, very small value of x, but that value of x will still be positive. So what will happen? For a very high value of y, you will have a very low positive value of x. That means a point somewhere over here, right? So you have got this as your generic point. This is again one of those points on your graph. And now what are we saying? We are then saying that if I take a highly negative value of y, so now let me take a very highly negative value of y. So that means your value of 0.1, because a was 0.1. So 0.1 to the power of minus 10 is the value of x, right? So I can then write this as 1 by 0.1 to the power of 10 to be equals to x. Now 0.1 to the power of 10 will be a very, very small value in the denominator. 1 divided by a very, very small value. Think about it. 1 divided by 0.01, that's 100. 1 divided by 0.001, that's 1000, right? So when you are decreasing the value in the denominator, your overall value will increase. A very low value in the denominator would imply a very high value of the entire of the value of x, of course, right? So for a highly negative value of y, you will have a very high value of x. That means a point somewhere over here. That means if I now join these 3 points, then I will get the graph of the log function. I'll get the graph of the log function lying between 0 and 1 when your base is lying between 0 and 1. Now there are important conditions for defining your log. So when I'm looking at this particular value, there are a couple of important points that you need to keep in your mind. If these conditions are violated, then your log is not defined, right? Let's have a look at those values. When is my log defined? My log is defined when my value of base, which is the value a over here, has to be greater than 0, and not equals to 1. So your base has to be always greater than 0 and not equal to 1 for my log to be defined, right? This is the first condition that you need to keep in mind. Why is it so? Because of the exponential function. So if you now look at the exponential function is not defined for a negative base, or for that matter, a 0 as a base, or for that matter, 1 as a base. So if that is not defined, then your logarithm function is also not defined for the value of a being 0 or less than 0. So a must be greater than 0 and not equals to 1 for log to be defined. Second important thing that you can observe from this entire graph is, if you look at the values of x which are negative, there's no output available. So if I take the value of x is -1, is there any output on my graph available for y? No, there is not. That means for my log to be defined, this input value present over here, which is the value of x, has to be always greater than 0. These are two most important conditions for my log to be defined. A lot of time they test you out during the paper, wherein when you solve a particular equation, you will get a value of a variable, which will in turn say that, let's say the base of the log is turning out to be equals to 1 for that particular value of the variable. In that case, you will have to reject that value of the variable. And the argument to that will be that your log is not defined for a negative base. Same is the case with the input value of log. What am I calling as the input value of log? I'm calling as the input value of log as x, right? So this input value of log has to be always greater than 0. For any of the variable, if this input value is turning out to be 0 or less than 0, then the log is not defined for that value of the variable, right? And we need to reject that value. Now, this was all about the graph of the log function. Now, the next thing that we're going to do is we will move ahead and we will look at some of the inequalities. So I'll let this graph remain there, but we will talk about a few inequalities. Okay, so just give me a second. This graph is important to solve those inequalities. So let the graph be there and let's move on and let's look at the inequalities. So these are some of those inequalities of log that we will be trying to solve. So one by one, I'm going to put them on the screen and we will try to solve these inequalities with the help of this particular graph. So this is the generic graph for my log function. So what was my log function that we were looking at? Just a second. So we were looking at a log function, which was log of base ax is equals to y. And this was the graph of that function, right? Now, what is the question saying? Let's treat this as a question. And what we need to do is we need to fill this blank as to what will be the comparison between log base AB and log base AC. What will be the comparison between these two values? Which one is greater? Which one is lower? Or are both of them equal? What it is? So now they're saying that the first condition is a greater than 1. A greater than 1 means what? I will be referring to this graph. Now they are saying that the value of B and C, what are the values of B and C? These are the input values. Input values implies what? The value of X. So that will be on the X axis. Now they are saying that B is less than C. That means if my value of B is less than C, B has to be towards the left of C. That means your arrangement has to be always like this, B and C kind of arrangement, right? So now what will happen? If you look at the value of the entire log, which is log of base AB, your value of log base AB will be somewhere over here, and your value of log of base AC will be somewhere over here, correct? Now, which value is higher? Of course, the output over here is higher than the output over here. So can I then simply say that higher is the input value, higher will be the output? So my inequality will be like this. So log of base AB must be less than the value of log of base AC. So if you just remember this graph, it becomes very easy for you to develop these inequalities and put them out there. Now, a lot of these books will directly give you these inequalities and will probably ask you to keep all of these inequalities in your mind. That's not possible for you to do that and get into an aptitude paper, because then you are putting too much strain on your mind and you have too many formulas on your mind, and it is very difficult to sit there in the paper and recollect any of these formulas for that matter. I would definitely not prescribe that, and that's the reason why I've kept these inequalities on this session to discuss it out with all of you, right? So ensure that you remember this graph, apply your basic condition. What did I do? I applied these two conditions and then I finally got down to this inequality as to what will be the relationship. right? So let me now remove some of these portions and then move on to the second inequality. Right. So let's move on to the next inequality. This is the second inequality. Now they're asking you, what can we say about log of base AB? If these are the two conditions given to you, A is lying between 0 and 1. A is what? My base. That means this is the graph that we will be referring to. And my value of B, which is the input value in this case, is to lie between 0 and 1. Input value is along the x-axis. So this is the graph that I'm going to refer to. So this is the graph that I'm going to refer to. And I'm going to say that the value of input has to be between 0 and 1. That means the value of input has to lie somewhere over here, right? Our input value has to lie somewhere over here. So what can I say about the output value? Output value is along the y-axis, and it is always positive for any value of B over here between 0 and 1, isn't it? So can I then simply say that log of base AB must be certainly greater than 0? Correct. Once again, an inequality that you don't have to mug up. You just have to keep this graph on your mind, right? Let's look at the next one. This is the third inequality that we will want to discuss. Now, A is greater than 1, and you are looking at log of base AB. That means this is the graph that you will be talking about. B is greater than 1. That means your input value, which is greater than 1. So the value of X is greater than 1. That means you have a value over here that you are talking about, right? And B is greater than A. This is an interesting condition. So let me take the value of log of base AB as, let's say, suppose the value P. So what will I say? I will say B should be equals to A to the power of P by my basic definition of log. Now let us understand this thing, that your value of B is greater than the value of A, right? And A and B both are greater than 1. A and B both are greater than 1. This will be possible only if my value of P is greater than 1. If my value of P is less than 1, then the value on this side will turn out to be lesser than A. And that then cannot be equals to B, correct? So let me take the value of 2 and raise it to the power of something which is less than 1, 2 to the power of 0.9. Of course, the value will be less than 2. 2 to the power of 0.8, that will be less than 2 once again. So the value of P over here must be greater than 1. And what was P? P was nothing but log of base AB. So log of base AB over here must be greater than 1 for sure, right? Once again, an inequality that you can figure out with the help of A greater than 1 as a graph. And second thing, what you can do is you can, of course, then look at these evaluations. Okay, if you are able to do all of these with the help of basic understanding of log, you will be able to get down to any of these inequalities. Don't have to keep anything on your mind. Let me remove this as well. Let's look at one more inequality. So this is another inequality that we would want to talk about. A is lying between 0 and 1. You are again looking at the base being A, and A is lying between 0 and 1. That means this is the graph that you will be talking about. B is also lying between 0 and 1. So the input value is also lying between 0 and 1. That means this is the value that you are talking about. And B is greater than A. Now B is greater than A, and A is lying between 0 and 1. So log of base AB, what can I write it? So if I write it over here, log of base AB, let me take that value as P. And A is lying between 0 and 1, B is also lying between 0 and 1. So B will be, what will be the value of B? The value of B will be A to the power of P. Now A is lying between 0 and 1. Think about it. We have already done this. Let me take the value of A as 0.1. If you now increase the power over here, the value, overall value will reduce, right? Take the value of 0.1 to the power of 1 and test, it will be 0.1. Take the value 2 over here, you will realize it is 0.01. If you increase this value, again, it will, the overall value will reduce, correct? So if I increase this value, the overall value will reduce. I need what? I need the value of, I need the value of B to be greater than A. So this value of B must be greater than A. So what can we say? If it is A to the power of 1, and if I increase it further from there, so the value will start reducing. So what will happen? I will have to keep the value of P less than 1 to be able to bring it equals to B, which is of course greater than A. So I have to increase the value. So 0.1 to the power of 0 will be 1. 0.1 to the power of 0.9 will be greater than 0.1. That is what I'm trying to convey over here. So if B has to be greater, then my value of P has to be less than 1 and greater than 0. So this will be the inequality. You will say that, how did you get greater than 0? Think about it. 0.1. If I take the value of 0.1 and I take the negative value of if I take the negative value of the power, so 0.1 to the power of 1 minus 1. So what will I get? 1 by 0.1. 1 by 0.1 is nothing but 10. So this value will become greater than 1, which is also not allowed because the value of B has to lie between 0 and 1. That means the value of P over here should be less than 1 and greater than 0. So it should be between 0 and 1, right? Once again, you don't really have to mug up any of these things. They don't really go to that extent of asking you all of these. But just in case, when we look at the books, we feel we are fearful of all of these inequalities. And that is the reason I wanted to discuss this out over here. Now, what I've done over here is I've put together some more inequalities for you to take the same process and try to do these inequalities. You can put your answers in the comment box of this video, and I will respond to you whether your answers are right or wrong. Of course, ensure that you are keeping this graph with you. So these are the inequalities. Take a screenshot of this and then try to solve these inequalities, fill these blanks up, and try to answer this thing, that what can we certainly say about these values present over here? What can we certainly say about these values present over here? Evaluate it on your own and put that answer in the comment box, and I will come back to you with the correct answers for all of these. Okay, so let's move on now. And the next thing that we will be looking at is talking about some of the properties of log, which you need to remember. Now, there are, of course, logics with which we can prove that, but we will not do this in this video because they're not going to ask you the proofs of any of these properties of log. Rather, these are the 5 properties that I'm going to talk about, and I want you to keep only these 5 properties in your mind. Keep nothing else on your mind because it is not required. So many books out there which are giving you so many properties to remember. I don't want you to be bothered about so many things and then get into the paper. So let's get on and let's understand these inequalities. The first inequality that the first property of log that I want you to remember is log of base A, B into C is the input value of log. So you will rewrite this as log of base AB plus of log of base AC. Second property that I want you to remember for log is log of base A, B by C, which is equals to log of base AB minus log of base AC. Okay. Third property that I want you to remember is log of base A, B to the power of C. B to the power of C is the input value. So what we will get? We will get C times of log of base AB, right? Same way, let me rewrite one more, which says log of base A to the power of B. A to the power of B is the complete number in the base and C is the input value. Then you can rewrite this as 1 by B log of base AC. Now we can combine these two identities of log and then can rewrite this as log of base A to the power of B and C to the power of D. This should be written equals to D by B log of base AC. This is just the combination of the first two identities, first two properties of log. Now keep this on your mind, and I don't really think that this is a thing that you will have to separately remember. You can always go by the first two that I've spoken about. These are interrelated to each other, so keep them on your mind the way I've written it on the screen. The next one that I'm going to talk about is a very, very important one, which is the change of base. So let's say, suppose you've got log of base AB and you wish to convert this log to the base of C. Okay. Now, if I wish to convert this to the base of C, I'm going to rewrite this as log of base CB divided by log of base CA. Log of base CB divided by log of base CA. Now, mark my words very, very carefully over here. A lot of times students make a mistake of only remembering it this way, that if I have log of base AB and I wish to convert it to the base of C, I can write it like this. Please do not make that error and remember this in this direction as well. So while solving some of your question, you may get down to this situation, and from there you want to write a number like this, right? Keep that on your mind. It is very, very important. So with the help of this, they derive something which is, they say log of base AB, and let's say suppose I wish to come down to a position wherein I have the value of B in the base. If I have the value of b in the base, how can I rewrite this? Let's pay attention to this. Log of base bb divided by log of base ba, with the help of the same formula that I've written over here. Now, log of base bb, let's try and evaluate the value of log of base bb. Log of base bb is, let's say, suppose equals to p. Then what will we be able to write? B is equals to b to the power of p. If this equation has to hold good, your value of base is same, your value of p has to be equals to 1. Your value of p has to be equals to 1. That means log of base bb will always be equals to 1. So what we will write? We will write the value of 1 by log of base ba. That means you can interchange these two values when you take it in the reciprocal like this. Now, this is not something that I want you to separately mug up. I want you to do this derivation on your own, probably 2-3 times, and you will be able to understand that this is not difficult to keep on your mind. As long as you have the logics with you, it is easy for you. The moment I ask you to mug up something, it's difficult. You might feel that I'm obsessed about ensuring that you don't mug up anything. It is actually the thing that has worked for us for so many years, with so many students out there who have gone there and cracked this paper big time. Okay, so if you also really wish to do this, this is a tried and tested approach. Talk about the generic concepts, keep those generic concepts on your mind, and generate an ability to apply those concepts on variety of questions out there. Okay, so let me remove this and let me talk about one more property of log, and with that we will be done. Okay, so let me talk about the fifth property of log, which is a to the power of log base bc. Now understand this thing, that I've raised this number a to the power of log of base bc. Now what I'm trying to convey over here is you can interchange the values of a and c. That means you can rewrite this as c to the power of log of base b a. This is the value, right? Now go further and rewrite and evaluate this a little bit further. If you have a to the power of log of base ab, then we had decided that we can change this a and b over here. So we can rewrite this as b to the power of log of base a, and log of base a is going to be nothing but 1. We've just done this on the previous property as well. So it will be b to the power of 1. So a raise it to the power of log of base ab can directly be written as b. You can remember this result. Also, one last thing that I want you to understand is when we had evaluated the graph of log, we had said that this will be the graph of log, right? This was when a was greater than 1, and this was when a was lying between 0 and 1, a being the base, right? You will realize that both these graphs are intersecting at this point. What is this? This is the input value of log, correct? Log of base ax equal to y, this is the graph. So x was the input value, and what is the input value? 1. This implies that log base a 1 will always be equals to 0. Whatever may be the value of a, of course, a should be in such a way that log is defined, right? So a should be either between 0 and 1 or greater than 1. So log of base a1 will always be 0 irrespective of the values of a. You can look at it with the help of this graph. You can of course express this in terms of the basic values as well. So if you write x is equals to a to the power of y, and you have to write the value of x as 1, then a to the power of y has to be of course 0 for any value of a which is not equals to 1, or anything which is for which the log is not defined, right? So your value of y will always be 0. So log 1 will always be 0. So keep this on your mind. Now, once again, the drill remains the same. I'm going to give you about 7 questions and will give you some time. The questions are not very difficult, but most of these questions have been picked up from the previous year's CAT paper. And that is what I want you to realize, that this is not a difficult topic. Prepare really well on this, get into the paper. The questions are not difficult at all, right? So let's move on and let's look at the first question. A minute's time to solve this, not a difficult one. Last 15, not really a difficult one. Let's have a look at this question. It says x is a positive quantity such that 2 to the power of x is equals to 3 to the power of log base 5 2. Now, if you remember the identity of property of log that we had spoken about, log of base a to the power of log base b c, a and c are interchangeable, right? So we had written this as c to the power of log base b a, correct? So can I then similarly interchange these two values? So can I then rewrite the given equation as 2 to the power of x equals to 2 to the power of log base 5 3? Why did I really do that? The reason was that I wanted to have the same base for my exponential part on either side of this equation so that I can equate the powers. So what am I now going to do? I'm going to say that my value of x is equals to log base 5 3, correct? Now, what is that they're asking you? They're asking you the value of x. X is log base 5 3, which is something that we don't find in the option. So we will try to evaluate each of the options and see as to which option can come down to this value of x. So log base 5 8 is of course not equals to log base 5 3, right? This is pretty clear. So this is of course not the answer. Let's evaluate the second option. 1 plus of log of base 5 3 minus of log of base 5 5, correct? Log of base 5 5 will be nothing but 1. So 1 plus log of base 5 3 minus of 1. This plus 1 and minus 1 will get cancelled out. What are we getting as this as the option? We are getting this option equals to log of base 5 3, right? That is what the value was over here. So option B is the correct answer for this. The only confusing option that I think where a student might make a mistake is option C. So be a little more careful with this. And beyond that, this question was not very difficult, a question coming from CAT paper. Okay. So keep this on your mind that the questions are not really difficult when it comes to a paper like CAT. Let's try and solve this. Another minute's time to solve this. Fifteen seconds more. Right. Let's have a look at this question. Not a very difficult one. Can I simply apply my log definition over here and can write this input value as 2 to the power of 3 as the base was 2. So I'm simply applying log of base a b equal to c being equals to b is equals to a to the power of c. This is something that we can write, correct? So can I then apply it over here and rewrite this as 5 plus log base 3 a is equals to 2 cube, which is nothing but 8. So log base 3a is equals to 8 minus 5, which is 3. So can I then rewrite the value of a as 3 cube, which is 27. A as 3 cube, which is 27. Now we need the value of a plus b. So let's look at this part as well. Again, apply the same thing. And then what are we going to get? We will get 4a plus 12 plus log base 2b, which is equals to 5 cube, which is 125. Now a is what? 27. 27 into 4 will be what? It will be 108. 108 plus 12 plus of log of base 2b is equals to 125. That means this value is 120. So log of base 2b should be equals to what? 5. That means the value of b should be 2 to the power of 5, which is 32. Which is 32. So what should be the value of a plus b? The value of a plus b will be 27 plus 32. That's going to be 59. Please ensure that we do not mark 32 as the answer. A lot of time people get into a habit of getting to this final value of B as 32. And then the moment they find something in the option choice, which is similar to what you are getting on your notebooks, you tend to mark that as the answer. Please do not get into that habit of doing it, right? Let's move on. Again, this was a question coming from one of the CAT papers. Need to understand CAT is not really difficult as far as log is concerned. Okay. Let's move on. Let's look at the third question. Take your time and try and solve this. Take a minute's time. Last 30 seconds. Vector. Let's have a look at this question. Now, this question says that you have got the value of log base 3x and log base 12y equals to a. They've given you this thing. Now they're saying where x and y are positive numbers, g is the geometric mean of x and y. What is the geometric mean of x and y? X into y to the power of 1 by 2. This is the geometric mean. So this is the value of g. Now they are asking you what is the value of log base 6g, right? And they've given you this equation. Can we apply the basic definition of log once again and write the value of x as 3 to the power of a and write the value of y as 12 to the power of a? We need the value of x into y over here. So let's try and calculate the value of xy over here. It is 3 to the power of a multiplied by 12 to the power of a, which we can very easily write it as 36 to the power of a. 36 is nothing but 6 square. So let me write this as 6 to the power of 2a. This is the value of g. Sorry, this is the value of xy. Now g was what? Xy to the power of 1 by 2. So the value of g should be nothing but 6 to the power of 2a to the power of 1 by 2. So can I then simply say that the value must be 6 to the power of a? So g must be equals to 6 to the power of a. Now, what is the value that they are asking you to calculate? Log base 6g. So log base 6, and what is g? G is nothing but 6 to the power of a. 6 to the power of a. So you can rewrite this as a times log of base 6, which is nothing but 1. So you'll write that value as a. So log base 6g was nothing but the value equals to a. Once again, a question coming from one of the CAT papers. We need to be very clear about this. Paper is very doable as far as log is concerned. Let's take this as a standalone topic in algebra and try and at least get 1 or 2 questions right from there. Most certainly you are getting at least 1 question. You may end up getting 2 questions on the paper, which is a big set of questions. Just solve these few hundred odd problems on logarithm, and then you are good on that paper for at least those 2 questions on the paper. Let's move on. Let's look at the question number 4. Again, a minute's time to solve this. Last 20 seconds. Right. Let's have a look at this question. It says you have a base which is 0.008. How can I think about it and try to probably make it look a little more better, I can say, and that will make me a little more comfortable. This can be written as 0.2 whole cube. Okay. So can I rewrite this equation which is given to me as, or rather this expression as, log of base 0.2 whole cube of this root over of 5 plus of log 3 root 3 can be written as 3 to the power of 1 by 2. 81 can be written as 3 to the power of 4 minus of 7. This is how we will go about doing this expression. Now 5 is again a power of 1 by 2. So that 1 by 2 will come in the numerator. What is the identity that I'm trying to apply? Log of base a to the power of b and c to the power of d. Right? So we will write this as d by b log of base ac. Right? So again, 5 to the power of 1 by 2, take that 1 by 2 in the numerator, take this 3 in the denominator and rewrite this as log of 0.25. Same way over here, 4 goes in the numerator, 1 by 2 goes in the denominator. You will have 8 log base 3 minus of 7. This is the value. So what do we get over here? We will get 1 by 6 log of 0.25 plus of log base 3 is 1. So 8 minus of 7 will then also turn out to be equals to 1. Now this is the expression that we have. We have to, of course, remove this log because all of these options which are given to you are numeric values. So we will have to calculate this value. Let's see how can we calculate this as well. So 1 by 6 and 5 and 0.2. 0.2 can also be written as 1 by 5. This is something that we can write. Right? So instead of writing log of base 0.2 and 5, can I rewrite this as 1 by log of base 5 and 0.2 over here plus of 1? And post this, I'm going to write log of base 5, 0.2, 0.2 as 1 by 5. So 1 by 6 times log of base 5, 1 by 5. Just a bit of modification to our expression. That's it. Nothing more than that. Right? Now go further. What can we write? 1 by 6 times log of base 5, 1 minus of log of base 5, 5 plus of 1 over here. Let's go further over here. Log 1 is always equals to 0. So can I then simply say that this is 0 and log base 5, 5 is of course nothing but 1. So what we will get? 1 by minus of 6 plus of 1. So what are we getting? 1 minus 1 by 6, which is nothing but 5 by 6 as my value. Again, the question was not very lengthy, not very difficult, very doable set of questions. Okay, let's move on and let's look at the next question. Take your time, a minute's time to solve this. Last 20 seconds. Right. This may need a bit of understanding of quadratic equation. So when you are saying that this is a quadratic equation in terms of x, you have equal to 0 that has gone over here. So that's the quadratic equation that you are looking at. And if you want the roots to be real and distinct, your value of discriminant must be greater than 0. It should not be equals to 0 as well. It must be greater than 0. What is the value of discriminant? Discriminant is nothing but b square minus 4ac. b square minus 4ac. What is the value of b square minus 4ac over here? 16 minus 4 whole square will be 16. minus of 4 into the value of a, which is the coefficient of x square, which is 1 in this case, into c, which is minus of log base 2a. So minus and minus will become plus log of base 2a. This value must be greater than 0. This value must be greater than 0. 4 is common to both the terms, for this term and for this term. So I will take 4 common and put it under 0 and make it 0. What will I get? I'll get 4 plus log of base 2a to be greater than 0, right? Which again can be written as log of base 2a greater than minus 4. That means my value of a must be greater than 2 to the power of minus 4, which is 2 to the power of minus 4. Let me write it over here. And a is greater than 1 by 2 to the power of 4. That can be written as a is greater than 1 by 16. Right? So the answer to this question is a greater than 1 by 16. Now I want you to think about one more thing. When I say that, let's say, suppose if you are getting to this situation, but instead of getting a base as 2, if I have the base as 1 by 2 greater than log base a minus 4, what should be the answer for this? Think about this and comment in the chat, comment in the description, comment in the comment section of this video, and then I'll respond to that, right? But try and evaluate this as to what can we say about the value of a in that case where the base is less than 1 now. It is 1 by 2, right? As of now, let's move on to the next question, question number 6. Take a minute's time again to solve this. Take about a 15 seconds more. Right. Let's have a look at this. Now over here, if you look at it, your value of base is same over here. So can I combine these two logs and rewrite this as log of base 5 x plus y into x minus y, which will of course be nothing but x square minus y square. That value must be equals to 3. Can I then rewrite this and say x square minus y square is equals to 5 cube, which is nothing but 125, right? Basic definition of log and the application of that. Now let's look at the second equation which is given to you. Log base 2y, log base 2x, and log base 23. Can I take everything on one side and then try to think about it? What we will get? Log of base 2y minus of log of base 2x plus of log of base 23 equals to 1. Can I combine this entire side like this, which is log of base 2, 3y divided by x to be equals to 1. It's a simple log a minus log b plus log c combination of that, right? So the positive values you will multiply and the negative value you will take it in the denominator, right? So log base 2, 3y by x is equals to 1. Again, apply the basic definition of log. You will realize 3y by x will turn out to be equals to 2, right? Now I have two equations in x and y, and then I can go ahead and solve this. So my value of x will be what? 3y by 2. My value of x is nothing but 3y by 2. So that is 9y square. I'll rewrite over here. X is equals to 3y by 2. Replace it over here. So you will get 9y square by 4 minus of y square equals to 125. So we will get what? 5y square by 4 is equals to 125. So this is going to be equals to 25. Y square will be equals to 100. So y must be equals to 10. I'm not taking the negative value of y because that's one of the input values over here. So value of y must be equals to 10. Now, if the value of y is 10, put it back over here. What we will get? You will get the value of x as 3 into 10 divided by 2. That's going to be 15. Correct? And they are now asking you the value of x into y. Be very careful while marking the answer. They might give you x and y in the option choices. Look at this, x plus y is there in the option choice already. Please do not mark that as the answer. They've asked you x into y, and x into y will be what? 150. So option D will be the correct answer for this, right? Let's go ahead and look at one last question for the day. Question number 7. Take a minute and a half's time to solve this. Last 30 seconds. Right. Let's have a look at question number 7 and try and solve this. It says log base 1281 is equals to p. Correct. So can I then rewrite this and write it as log base 12 3 to the power of 4 equals to p, which is 4 times log of base 12 3. Just simplifying what is the value of p. That's it. Right. Now we need to find out this value of this expression. 3 times of 4 minus of p divided by 4 plus of p. Right? What is the value of p? 4 times of 12 log base 12 3. So 4 minus of 4 times of log base 12 3 and 4 plus of 4 times of log of base 12 3. Correct? Take a 4 common and that will get cancelled out. So what we'll get? 3 times of 1 minus of log of base 12 3 divided by 1 plus of log of base 12 3. Right? Go further, it will be what? 3 times of log of base 12, 12. Now think about it. Why am I doing this? I'm looking at log base 12, 3, and I know I can reduce a log in the numerator if I can express this one as a log. And the best way to do that is log base 12, 12. Can I then subtract a log base 12, 3 from here? Divide that value. And again, in the denominator, I'm using the same thing, log base 12, 12. Plus of log of base 12, 3. Correct? Now, look at this numerator. What can we rewrite this as? 3 times of 12 by 3. Log base 12, 12 by 3. 12 by 3 is nothing but 4. So I can simply write this as log base 12, 4 divided by same thing over here, log base 12, 36. Log of base 12, 36. Now, understand this thing. We had done a property of log, which is change of base that I had spoken about. Log of base AB, and let's say suppose I wish to convert this to the base of C. What did we do? Log of base CB divided by log of base CA. And I had told you to remember this in this direction as well. Are we getting down to a similar situation over here? Look at your right hand side. The base is same in the numerator and denominator. Log base 12, 4, log base 12, 36. Can I rewrite this as 3 times log of 36 over here and 4 over here? Very easily I can do that. Look at this, right? So A was over here, so A goes in the base, so 36 goes in the base and 4 is over here. Let's rewrite the entire thing. Again, this is 3 times of 2 by 2 log of 6 2. What have I done? 36 has been written as 6 square and 4 has been written as 2 square, and then 2 has been taken over here. So this will get cancelled out. What we will be left with? 3 times of log base 6 2, which is log base 6 8. This is the value. So option A will be the correct answer. Again, a question coming from CAT paper, and my sincere suggestion once again is solve about a 50 to 100 odd problems on log at a stretch after doing this video, and apply exactly what I've asked you to do. There's nothing more required on log for sure, because I have not come across a question on the CAT paper which you cannot do by the way by what all we have discussed in this video. So all the essentials to solve any of the questions on these aptitude papers is there in this video. Watch this video, solve about 50 to 100 odd problems. You are through with this. I have also given you a few inequalities to work around with. Please ensure that you put your comments in the comment section of this video, and I'll be happy to answer any of those things, right? So that's about it for this video, guys. Thank you so much, and stay tuned for further videos on CAT 2021. Thank you so much.